Hello everyone. In our daily life, we come across number of situations which may or may not happen, and we are not sure of the outcome. For example, by just looking at the clouds, I can say possibly it will rain today, but it will rain or not sure. So there are many situations like that. So when we start calculating the possibility of something to happen or not to happen, if we want to calculate that possibility mathematically by assigning some value to it, that is called probability. So we are going to learn about it in my later videos. In today's video, I'll share with you some terminology associated with it. Like here, I'll share with you the three parts. I will share with you what do we mean by random experiment. So these are the basic terms associated with the probability. So the random experiment, very frequently used word, and outcomes, sample space, trial, events. These are very starting basic terminology. So let us see one by one. So starting with the random experiment. What do we mean by this random experiment? So the experiment which we cannot predict its result, but we know what are the possible result. It means it has more than one possible outcome, and you can say it is not possible to predict the outcome in advance. Let us see with the help of examples, right? So I am taking the first example here, tossing a coin. So when we toss a coin, we know that either head will come or tail will come, but before throw we cannot predict. So it means it is throwing a coin is a random experiment. Then there is another experiment, throwing a die. It is a cuboid shape and there are 6 faces, every face having a number 1, 2, 3, 4, 5, 6. So again, before throw, right, we cannot predict which number is going to appear. So it is also a random experiment. Then drawing a card from a pack of a deck which has, there are 52 cards. We play these cards with the different suits with different colors, and if for example we want to draw a card from it without looking at it, so we cannot predict in advance that which card I am drawing. So again this experiment is random because we know what are the possible cards in it, but we cannot predict before doing this activity of drawing. So this is also a random experiment. Then we have a one more example, drawing a marble from a bag. I have a bag, for example in that bag there are number of marbles for different colors, and I just without looking at I want to draw one of them. Before drawing I don't know which color or which marble I'll draw. So here again this activity is a random experiment because we know about the situation that there are these many marbles, and these are the possible outcomes, but we cannot predict in advance. So all these situations, so if we cover, so you have observed that anything, any experiment or any activity which has more than one possible outcome and one cannot predict it in advance, it means we are dealing with the random experiment. Then there comes a term, outcomes and sample space. Now obviously when we are performing any activity or any random experiment, we get a result. So those possible results are called outcome, and when we list all possible outcome of that particular event or random experiment, we call it a sample space. So we denote it by letter S. So when you club all the possible outcome and write down within a set, it is called a sample space. Let us take an example. I am taking again an example of a tossing of a coin. So this is an experiment of tossing a coin. Outcome is head or tail, right? And the sample space is S is equals to H comma T. So you can use different symbols, but very frequently we use the letter capital S for that, and we use H for head and T for tail. So this is also a sample space. And similarly, if I pick the example of throwing a die, these are the outcomes and the sample space is 1, 2, 3, 4, 5, 6. So we can write down, means all possible outcomes. And let us take one example of, let us find out sample space. Let me do this activity here. I want to find out the sample space of coin tossed thrice. It can be 3 coins drawn together or tossed together, or you can toss the same coin 3 times. So both will have the same sample space. So in a first throw I'll get head or I'll get tail, right? Or for example, if I again want to do this is my first toss, right? Either I get head or I get tail. When I take a second toss, what happened? Either first with head I'll get tail, or possible say head, you can write anything, or possible you can get tail, right? And or you can get first tail and then head, or tail with tail. So in the second throw you will get this thing. Now when we are doing third time, so maybe when head is going, it can give you again head, or it can give you a tail. Or other possibility is when you are getting head with tail, maybe you get again head or maybe you get a tail. So when you are having this toss, again you get a head or again you get a tail. Or you can say that when two tails are coming, maybe in the third throw you get a head or maybe you are getting a tail. So in this 3 toss, we may get these possible outcome. I am using it with the tree because when the toss are increasing, then not to miss any chance, we can make use of this tree and we can write down the sample space like this. I'll just see the tree branch. It means one of the outcome is head head head, one of the outcome is head head with tail, and then we have a head tail head, then we have a head tail tail. You can write anything in any order. This tree is just giving us a very clear confirmation that I am not missing any of the outcome. So then we have a tail tail head and we have a tail tail tail. Again, you know that in set you can write anything first or anything later, it hardly matter, order doesn't matter over here. Matter is, are we writing all the outcomes or not? So there are 8 outcomes here, right? And similarly, when we discuss about, say, find the sample space associated with this example experiment of rolling a pair of dice. Now when we throw the die, we get these many outcomes. Like you can take two. See, the sample space remain the same. For example, either you question could be what is a sample space when two pair of die is rolled, or when a die is rolled 2 times. So both will give us the same answer. So here 1 with 1, 1 with 2, 1 with 3, 1 with 4, 1 with 5, 1 with 6, or you can say 2 with all the 6. So see, here again the point is not to miss any outcome. We can make a pattern like you pair 1 with all 6, then 2 with all 6, 3 with all 6, 4 with all 6, 5 with all 6, 6 with all 6, and this way you can write down the possible answer. So that is about the there are 36 outcomes, right? So sometimes it is important to learn the strategy also, how we should write down. And then we have a last part of this video is trial and event. Any particular performance of a random experiment is called trial, right? We are performing something, so it is called trial. And outcome or combination of outcomes are termed as event, denoted by is. When you collect some or some of them or one of them, they are called the event of that random experiment, and we can denote it by E or any other letter. So it is a subset of sample space. Let me take an example. For example, consider the experiment of throwing a die. Let the event E be getting the even number. Now when we throw a die and we know that these are the possible outcome, and we want to find out what is the entries of getting even number. So either you get 2, 4, 6. And similarly, if a die is rolled and event of getting less than 3, so which of the following is the right in the same? So getting number less than 3, so this B option is correct. So this way we can talk about number of events of a particular experiment. Hope you have understood these 3 main terminologies. Thank you.